Hello guys, welcome back to my channel. So today we're going to configure IPSEC VPN. So this is basically a continuation of what we did the last time, except that today we're going to, because last time we did this part, okay, this is the part that we did last time. And so right now I added another part, which is like a different site. And you're going to consider this like maybe this is a company that bought another company, so they have to merge, and for them to merge we have to link them up through IPSEC VPN tunnels to secure the traffic. We don't want the traffic to go through the internet without encryption. So the IPSEC tunnel is going to provide the encryption required for this to happen. Yes, so we do have these two companies. So let's say the existing company is in Montreal, located in Montreal, and then a new company is in Calgary. So we're going to merge them up using IPSEC tunnels. So which means that the company in Montreal is already functional and the one in Calgary is already functional. All we have to do is to merge them up with the IPSEC tunnel. So let's just test connectivity first in Montreal. Let's say we want to ping the gateway here from, let's say, DNS server. Go in there. So first of all, the IP scheme that I used here is 10.10.10.0/24 for this segment of the network, which is at Montreal, and then for the segment in Calgary, okay. The IP scheme is for the LAN segment is 172.16.2/.0/24, and then the 192.168.10.0/24. Okay, that's the LAN section. And the internet facing section is, we have on the Calgary side, on the edge router, we have 23.23.23.0/30, and on the Montreal side this 64.64.64.0/30, and of course we have point-to-point router here, which is on the internet on the ISP side. So all right, so let's test connectivity first on the Calgary side. Okay, let's see if from the PC we can ping the edge router on the internet facing router in Calgary. Let's go into the PC. Okay, I actually did a test already. Let's do it again. So we're going to ping 172.16.2.3, which is this IP. This is the this interface gigahertz 0/1 on the edge router. Okay, so if we ping that, if the ping is successful, it means we can ping up to this point. Okay, but we cannot ping anywhere out of here. Okay, because first it's not yet configured. We have to configure that, and then we'll try to ping the internet facing port, and then we'll try to ping the other side, and of course the ping is not going to be successful. So we've tested this side, it's good. We can ping the edge router. Now let's test the Montreal side, if we can ping the edge router. So let's try to ping from the DNS server, which is 10.10.10.20. We'll try to ping the edge router, which is 10.10.10.1. Okay, that's the gateway here. So we're going to ping 10.10.10.1. Okay, that's successful. So basically from here we can ping this edge router. Okay, that's the IP address on this router. It's not yet been configured except the LAN LAN port of the router. Okay, so in the same way we can ping all these other servers here. Let's try them. Let's say from here, let's try to see if we can ping the mail server and the FTP server. So for the mail server, it's going to be .30. Yeah, I know why we're not pinging, because we haven't done any configuration yet on the router. Or maybe I didn't set the IP on the mail server, but I'm going to check right now. Alright, so I checked. The reason why we were not able to ping the mail server was because the IP address on the mail server was not set right. Okay, so I just corrected it. So let's try to ping the mail server and the FTP server from the DNS server. Do the same ping again. Yeah, that should be responding. Okay, and the FTP server. Okay, and as we said, this side of the net, the Montreal side, is all functional. Everything should function. So what I did is I actually configured all these servers. Okay, and so these services are going to be reachable from the Calgary side. Okay, once we have our IPSEC VPN set up, right? So also there's an access point here with one client, which is a tablet. And for that tablet, we gave it an IP address of 10.10.10.50. That's the IP we gave here. Okay, .50. And we also want this tablet to be able to receive emails. Once the VPN is working, the tablet should be able to receive email from the PC. Okay, so PC is going to be like user 1 and tablet is going to be user 2. So I went in there and configured email services. So this is going to be user 2 tablet. Once everything is done, we should test email from this PC to the tablet, and the PC is user 1. So if I come here, so I configure the PC to be user 1. Okay, and also I'm using the Gmail server. Okay, so the Gmail server, the IP we already checked is working. The services for email, I configured user 1 and user 2. So user 1 with the password, and this is the domain. Okay, so this domain, the domain has been actually set up in a DNS server. Okay, so if we're going to DNS server and I check services, DNS enabled. So for the domains, I pointed to the IP address of the SNMP server. Okay, it's 10.10.10.30. And also I created another a record for just general internet, dimbase.com, which is 10.10.10.20. Okay, so the FTP server as well, I created 2 users. I gave an IP address which we could already ping. It was working. So this under services and FTP, I created 2 users. User 1 with the password of Cisco123, user 2 with the password of Cisco123. FTP is enabled. So this, all I'm doing is just to tell you all this section is functional, and we just have to create our IPSEC VPN and test that the services are correct. Okay, now for IPVPN to for IPSEC VPN to work on the site-to-site connection that we're trying to set up here, there must be full connectivity between Edge Router 1 and Edge Router 2 going through the ISP. So we have to ensure that there's full connectivity. Okay, that this router can actually reach this one on the internet facing IP addresses, and if that's possible, then that's only then that we can configure the IPSEC VPN. Okay, so right now let's get into the configuration of the IPSEC VPN, of the full mesh connectivity. We're going to set it up using OSPF, dynamic routing protocol. So let's start with Edge Router 1 in Calgary. Yeah, so let's go into the Calgary router. As I said, it wasn't configured yet. It was configured, but I had to remove part of the configuration just to enable the IPSEC VPN configuration. So if I do show run, you're going to see there's no configuration on the serial interface. Serial 000, no IP address, and what else? Okay, I need to remove this. This configuration was set up for different for something else for the previous video, so I'm going to have to remove this one. Let me see, terminal, because if I don't remove it, it's going to interfere with the what we're trying to set up. Copy, no, paste. Okay, maybe show run again. Okay, we don't care about this access list, we're not going to use it. Yeah, we need this route. This route, default route tells us that if any traffic from this Calgary site wants to go out internet, it has to go out through the serial 000. Okay, so this is the internet facing port of the Calgary router. So we're going to keep this default route, and then the LAN site OSPF is running. That's what permits this multi-layer switches to be able to talk to the edge router. So we're going to keep that one, and then serial 00 is not configured, and so let's configure it right now. So let's go back in there. I'm going to probably just lower this a little bit like this. So configure terminal. Say interface interface 0.0.0, no short. IP address, we're going to give the IP address 23.23.23.2. So it's a /30, so it's 255.255.255.252. Okay, and then we'll go exit here. Then we're going to create configure OSPF that's going to run between Calgary, Montreal, and the ISP. Okay, so route the OSPF. Let's give it let's give process of 111. Okay, we'll give it a router ID 1.1.1.1. okay, and exit out of there. Now we're going to configure OSPF only for this interface. Okay, so that we don't want to configure OSPF 111 globally. We just want to configure only for this interface. So interface 0.0/0/0 IP OSPF process ID 111. I'm going to give area 1. Okay, area 1, enter. Okay, and if I do show IP route, okay, we have this default route. That's good. So OSP is learning OSPF from this, is letting OSPF on the other it's learning OSPF on the that's the process ID 1 of the OSPF, but this route is not going to be redistributed to internet, so we're going to see it on the other router when we configure OSPF on the other ISP and the router in Montreal. So just to be sure that our LAN subnets are not going to be routed through the internet, because we don't want this LAN subnets to be routed on the global internet. Okay, so what we're going to do is show IP protocols, show IP protocols, Okay, so we can see what protocols are being routed on this category router. We have OSPF process 1 and OSPF process 101, and process 1 is the LAN section of the edge router, which is routing these networks, and on the internet facing portion, it's going to be routing only what we're going to configure right now. For now, we're not seeing network routed. All right, so right now let's configure the ISP router. We're going to configure configure routing for ISP. So let's go into the router there. We're going to lower this out. Enable, configure terminal, give a host name. And then we give IP address on the serial 000. Okay, this one. So this serial 000, we're going to give IP 23.23.23.1 here and .2 on the edge router. So on this side, it's going to be 64.64.64.1 here and then .2 on the edge router. Okay, so let's do it. So it's interface serial 0/0/0, no short. IP address, we're going to give it 23.23.23.1. There's a /30, so it's going to be 252. Okay. We're going to give a clock rate. If you can see here, there's a clock for point-to-point interfaces. If one of them is a clock rate, the other side must not be a clock rate. So on the other interface, we did not configure clock rate, but here we have to configure clock rate. Okay, same thing we're going to do on the other interface facing a Montreal router. So say clock rate. If it's 64,000. Let's see, 18 seconds, I think. 18 seconds. Bit per second. Okay, so 64,000. Let's give it 64,000. And then exit from there. Then we'll configure also for interface S001. No short. IP address 64.64.64.1. Also going to give a clock rate. Okay, we'll exit out of there. Now we're going to configure routing. OSPF what's going on here? Router OSPF 1. So we're going to give a router ID of 3.3.3.3. Okay, and we give a network statement. So everything attached to the ISP router is going to be routed on OSPF process 101. Okay. So everything attached to the OSPF router, all interfaces will be advertised on OSPF process 111. Okay, area 1. Enter. And for ISP, this should be done. It should be okay. So let's just double check just to be sure. We should be able to ping the category router. By the way, before then, let's show IP OSPF. Okay, We'll show the route. Okay, so this is interesting because we don't want the LAN network to be advertised on the ISP side. Okay, so we all networks we're seeing right now are all public internet IP address. Okay, so we don't have the 192.168 anything, okay, or 10 dot anything. So now with that, we are not getting OSPF routes yet because we are on the ISP, and the ISPs are directly connected to the Montreal and Calgary point-to-point network. That's why we're not seeing OSPF routes. So what we're going to do is we're going to try to ping the Calgary site because it's already configured. So it's going to ping, if we say ping 23.23.23.2, that ping should respond. But if we try to ping the Montreal site, which is not yet configured, that ping should fail. So if we try to ping this internet facing side of the Montreal router, it's not going to work. Let's try that. Ping 64.64.64.2. Okay, that's not working. Yeah, as expected, ping to the Montreal side didn't work because it's not configured. So let's get into there and let's get into that router and configure it right now. So this is the Montreal router. Enable. So first we will have to configure the interfaces. Zero zero /0/0 no shot. IP address. So this one is going to be 64.64.64.2 255.255.255.252, so /30. Okay, and we exit out of there. Okay, now next thing we have to configure is a router ID, router OSPF ID. So router OSPF process 111. It has to be the same process for the three routers, ISP, Montreal and Calgary routers. It's the same process. Well, it doesn't have to be the same process, but just for the sake of making things more clear, more visible, more clear. So I use the same process ID. It doesn't have to match actually. So let's put the router ID. Okay. So router ID is configured. Now we're going to exit out of there. By the way, I should let's add this command. No, we're going to add that one later. I'll exit out of there. And we do go into the interface, because what we want to do is just the same like we did on the Calgary site. We don't want to advertise OSPF globally on this Montreal router. We want to advertise only on the internet facing interface of the Montreal router. So we're going to go into interface 0/0/0 IP OSPF process 1 area 1. Okay, and then we exit out of there. Now next thing is we have to make sure any traffic that is sourced from the LAN side of the Montreal router, it has to know this serial 0/0/0 at its internet facing interface. Okay, so for that, let's give a default route, IP route. Okay, I think I made an error there. Let's see where the error is. Alright, so I actually made an error in one of the zeros, So now it's okay. And so now we define a default route. If anything wants to go out internet from the LAN side of the Montreal router, it has to only go out through this 0000. That's what we just created here. And also we have to go into the router configuration mode, and then we define we add another statement, default information originate. So let's go into router OSPF 1. We just say default information originate. Okay, it basically says that this is going to be our default router for internet traffic for anything on this LAN side of the router. Alright, so technically the configuration of the Montreal router, Edge router 2, should be done. Okay, so let's do show IP route. Okay, now we can see OSPF routes. Okay, and the reason we're seeing OSPF route now is because this 1023.23.23.0 network is coming from remote side. Okay, it's not directly connected like the ISP. Okay, that's why we're seeing it as OSP route. I also see the default route. Okay, the default route that we just set. Okay, so everything should be good at this point for full mesh connectivity at the globally. Okay, so there should be full mesh connectivity between Calgary, Montreal, and the ISP. Okay, let's test it. If I go in here, this is the Montreal router, and I try to ping the ISP 64.64.64.1. Ping should respond, and I should also be able to ping the Calgary router, which is 23.23.23.2. Okay, that ping is responding. So basically what that means is that we are ready to start our IPSEC VPN configuration. Okay, so what that means is that we are now ready to start our IPSEC VPN configuration. But before then, let's do one more ping from the LAN side. Okay, from the LAN side, let's try to see if we can ping the other side, just to let you know that traffic is not yet configured. We have to set it up. Okay. Okay, now as we noted, there's full mesh connectivity now on the globally from the Calgary to Montreal to ISP. It's full mesh connectivity. Now we can start configuring the IPSEC VPN. Before then, we have to test if this side, the Calgary side, can reach the Montreal side. Okay, that should fail because that's our goal. We want to make that happen. So let's go into. I just made I made a little change here. Instead of PC1, I just called it user1 because we're going to come back to user1 all the time instead of PC. And then for the tablet, instead of tablet, I just put user2. Okay, so let's go into user1, use a PC, and try to ping. First, we're going to try to ping the outside interface of the Calgary router. Okay, which that ping should work because that's what we said. We said if anything on the LAN side wants to go out internet, it has to go use the 0000. So let's try to ping 23.23.23.2. okay, that's the IP we put here on the 000.2 should work. Actually I did a ping already. That ping is working, but if I'm pinging the other side of the point-to-point connection on the ISPN, which is the .1 here, it's not going to work. Okay, that's not going to work, and the reason it's not working, of course, is because the traffic reaches the ISP, but ISP says, I don't know you, I don't have any route that goes back to 192.168.10. Okay, so the traffic actually gets to the ISP router, but he doesn't route it, doesn't reply. So that's why we get a timeout. So now let's try to ping. Technically, since ISP doesn't respond, we should not be able to have any traffic going to the other side. But let's just try it for the sake of trying. Let's just say we're trying to ping the internet facing port of the Montreal router, 64.64.64.2. Of course that fails, and if that fails, there's no need to test this other the LAN side, okay, because there's no traffic going in there. So right now let's start the VPN configuration, okay, the IPSEC VPN configuration. So in our next phase of configuration, we want to enable this IPSEC VPN. The traffic is still going to go out through the serial 00 to the ISP, but the ISP is not going to see that traffic as it should see. That it's not going to see the 192.168.10.0 or the 10.10.10.0. Okay, traffic is going to see it encrypted, so it's just going to see only the it's going to see traffic, but it's not going to be able to identify exactly what is it. So that's why we're doing the encryption through IPSEC VPN. So this I put ahead this process here that we're going to use to configure it. The first thing we want to do, remember, this is packet tracer. We're not using like it's packet tracer, so it's all emulation router. The routing function is just emulations. So we're going to enable a security technology on each of these routers, which is already done, but I'm going to show you the process, which is right here. Okay, so this router is a 29. This is a 2911. Let me see. Let's switch to show version. It is show version. So it's a 2900 Cisco router. Okay, and let's see. I already enabled the security functions. So let's show version. Okay, okay, it's disabled. Okay, I need to enable it. I thought I enabled it, so I'm going to enable right now. And I think I actually thought I enabled the security function on this Calgary router, but I will do it right now. But just to compare with Montreal router, which is already enabled, if I go in there, I do show version. Okay, so we have security functions already enabled, which means we can do IPSEC configuration on the Montreal router. We can do it, but we cannot do it on the Calgary router. So to enable it, we have to use this command. And license boot module, and then it's going to be C2900 technology package, and then security K9. Okay, so let's enter that command, and it has to be one word at a time. So it's going to configuration mode. It's going to be license. Let me load this out just to be able to see. So it's license boot module, and then the model of the router is C290. Okay, and then technology package, and then security K9. And if we do question mark, we're going to see we have either disabled or to hit enter to apply. So now it's applied, but we have to reload the router, okay? Because if we don't reload the router, it's not going to take effect. So I'm going to exit here. I'm going to first save it and then reload the router. Confirm. Okay, router is reloaded. Let's check if security is enabled on this router. Show version. Still disabled. I might have to do something else. Alright, so basically what I did is I realized that this router, the router that was here was a 2900 series router. I had to replace it with the same router that's on the Montreal site for security functions to work. So for some reason it didn't want to accept the 2900 series router, didn't want to accept the security functionality. So let's go into Calgary router and do show version. Now we can see security is possible. We can do security configuration on this router, okay, same like on the Montreal router. And all I did was to make sure that this to add this configuration: license boot module C1900, technology package, security K9. That's all you need to do to enable this to have this security functionality on the router. Okay, so now canceling all of that. So this is the procedure for configuring the IPSEC VPN. So the first we have to enable routing reachability between H routers 1 and 2 and the ISP, which we already done. This is done. And then next we have to configure the IPFace1 is account policy, which basically means we want this router to be able to be able to do a handshake. Okay, so to just configure a handshake between this router and that router before even sending traffic. Okay, we have to first of all configure handshake, this IPFace1, and then number 3 is to define what's going to be the interesting traffic that's going to be routed on the VPN. Okay, what is the traffic that you don't want ISP to see? The traffic that you want encrypted is going to be, we want this 192.168.10.0/24 to be able to reach the Montreal site, and we also want the Montreal site 10.10.10.0/24 to be able to reach the Calgary site. Okay, and we want other traffic routed without ISP being aware. So we're going to set those VPN policies and IPFace1, IPFace2 on the IPSEC tunnels. Okay, so this is the process here. This is the process. Okay, let's bring it up here. Okay, this is the process. So after adding the access list, the interesting traffic, we're going to configure the IPFace2, which basically means we're going to create a policy that for the security functionality to work. Okay, so after that we have to create a route map that basically crypto map that basically ties IPFace1 to IPFace2. Okay, the next is going to be to apply that crypto map on the global facing interfaces of the edge routers. Okay, so for Calgary router it's going to be 0.0.0.0, and for Montreal router it's going to be 0.0.0.0 as well. So let's get into it. Okay, so we're going to start with the Calgary router, and then we end up with the Montreal router. Okay, so as we said, the first step is done. So now we're going to do the step 2, which is configure IPFace1. So let's go into the Calgary router, configure terminal. We'll say crypto is account. Give a policy. You can give a policy policy 10. Enter. And if we do a question mark, you can see we have various options. We can provide authentication, encryption, group number, hash, lifetime, whatever. So some of those options we're going to take as by default. So let's give encryption. We're going to give encryption of I'm going to give encryption IS, which is fairly solid, and then 256. I think we do have an option here, so 256 bits, which is strongest. Okay, and then we give authentication. It's going to be pre-shared. Authentication pre-shared. and then we'll give a group, Diffie-Hellman group. So we have Diffie-Hellman group 1, 2, and 3. We're going to give group 5, and this group is going to be the same on the other side. Remember, IPSEC phase 1 is for the handshake configuration. Okay, so it's going to have to be the same on the Calgary and the Montreal side. We exit out of there. Now we provide a key for the encryption. Crypto is the key. Let's call it Cisco 123. Okay, that's going to be the key. We're going to give the same key on the other side, and then we're going to do that key is going to be shared to the PS side, which is on the address 64.64.64.2. okay, this is the one side interface IP address of the Montreal router. That's .2. So say enter. Now we have to provide interesting traffic. Okay, we have to provide interesting traffic for this. So what I mean by interesting traffic is we have to do step 3, which is to configure the ACL that we want encrypted. That's the traffic we want encrypted through the tunnel. So basically, as I said, we want this traffic from 192.168.10.0 to be able to get to the other side, to be able to get to the Montreal side. Okay, and the Montreal side LAN subnet should be able to get to Calgary. So let's get back to our configuration and provide the access list. Okay, create the access list. So it's going to be an extended access list. Access list. Let's call it number 150. Access list. Okay, number 150, which is extended access list. Say permit IP 192.168.10.0. the wildcard mask 0.0.0.255. okay, we want that subnet to be, we want this to be the source, and we want the destination to be 10.10.10.0. okay, subnet mask 0.0.0.255. okay, like this. So basically what it means is that we want this 192.168.10.0 to be able to get to the Montreal side. Okay, so when we get to the Montreal side, we're going to reverse this access list. Okay, so we do enter. Okay, access list is configured. That's step 3. Now we'll go to step 4, which is to configure the IPSEC phase 2 IPSEC policy. Basically what that means is we have to configure a transform set, okay, that permits that traffic to be encrypted. Okay, so how do we define it? Is the configuration we're going to do right now. It's going to be crypto IPSEC transform set, and we're going to give a name. Okay, let's call it my set, all in capital. And then we're going to define the hash. No, the encryption. We're going to define first the encryption. So ESP AES, and then we define the hash, which is going to be ESP SHA. Okay, so what that means is that our traffic is going to be hashed with a SHA algorithm and encrypted to AES. Okay, so that's what the statement means, and we're going to call this transform set my set. Now phase 4 is completed. Phase 4 is completed. Now we're going to tie IPSEC phase 1 and IPSEC phase 2 together. Okay, so we just completed IPSEC phase 2. So now the step 5 is to tie IPSEC phase 1 and IPSEC phase 2 together with a crypto map. Okay, so let's go into it. We're going to say crypto map. We're going to call it my map, and we give it a sequence of 10. So we're tying IPSEC to ISACAM. IPSEC to ISACAM. We're going to set the transform set. We're going to set the transform set and give the transform set name that we just defined above there, which is my set. We just defined it well. It's my set. I want to set the pair IP on the other end of the tunnel is going to be 64.64.64.2, and we have to match the IP address that we created. Okay, match address. So you're going to have to match the IP address we just created here, which is IP address 150. My match address 150. And we exit out of there. Now we're going to have to apply that crypto map on the global one interface of the edge router on Calgary. So it's interface 00/0/0. We say crypto map, and then we give the map name we created here, which is my map. Yeah, it's going to be my map. Okay, so once we hit that enter command, you see crypto map is now on. ISACAM is on. Okay, so basically configuration is done on the Calgary side. We have to do exactly the same thing on the Montreal side. The only difference is going to be is the pair IP is going to change. We also have to make sure that the crypto IPSEC phase 1 and IPSEC phase 2 are identical. Okay, IPSEC phase 1 and IPSEC phase 2 must have to be identical. Okay, so let's come here. Let's check our cheat sheet. So we've done all these steps. Okay, on the Calgary, we have to do the same thing on the Montreal side. So I'm going to configure now for the Montreal side, which is edge router 2. Okay, and I'm only going to comment on what is different from what we did on the Calgary side. Okay. So basically we give the same encryption strength. Give the same group number for the VPN. So now for the crypto key, we'll give the same crypto key, but the address is going to be the category site IP address, which is 23.23.23.2. Now we have to do step 3, which is to provide the interesting traffic, the ACL, configure the ACL. It's going to be the same like on the category side, except that the subnet is going to be reversed. So configure access list. Yeah, so the access list is done. That is step 3. Now we're going to go to step 4. For the access list, we want this site to be able to have access to this other side. Okay, that's what we just did. Now let's move the phase to step 4, which is to configure phase 2, which is IPSEC algorithm. Can give the same name. It's much better to give the same. Yeah, I think the names also have to match. We'll configure the encryption. That should be the same like on the category site. Then the hash. Okay. Yeah, so we configured the IPSEC phase 2, gave the same encryption and then the same hash like on the Montreal site. Now we're going to configure the crypto map to tie phase 1 and phase 2 together. Crypto map. Let's call it my map. The same name like on the other side. It really doesn't matter, but I think it does matter. But anyways, we're safer to give the same name. Sequence 10. So we're tying IPSEC to ISACAM. Enter. And now we're going to set the transform set. Set the transform set to the transform set we just created above, which is my set. And we set the pair to be on the category side. Set pair, which is on the category side, is 23.23.23.2. And then we're going to match the IP address, match the access list that we just created. Match address 150. Okay, let's double check here. Yeah, 150. We exit out of there and then we apply. Crypto map, my map. So technically, we've completed the configuration of the IPSEC tunnel on the Montreal site. Let's just exit out of there. Exit again. And if we do show crypto map, let's see. Okay, show crypto map. So what we see here is that we created a crypto map. Call it my map, sequence of 10. And we tied IPSEC to ISACAM, to phase 1 and phase 2 to phase 1. We set the pair on the category side 23.23.23.2, and then we created an interesting traffic with extended IP access list of sequence 150, allowing this subnet 10.10.10.0 to talk to 10.192.168.10.0, and yeah, so, and we applied it on the serial 0000 interface. So let's do show crypto IPSEC Security Association. So it's it's not just we're still waiting for the connection to set in. So a while ago the tunnel was not yet up. Let's check again. Okay, tunnel is still not up. Let's do show crypto IPSEC Security Association. So we can see the local network here, okay, and the remote interesting traffic is 192.168. That's properly configured. You see the pair when viewed from the Montreal side is 23.23.2, which is on the Calgary side, the VPN port here. See, there's no traffic going through the tunnel. The tunnel is created. Apparently the tunnel is created, even though it's not yet showing status up. But so we don't see any packets encapsulated or decapsulated through the tunnel. Okay, so let's check again. All right, let's check on the Calgary side if the tunnel is up. Show crypto okay, yeah, so we see the tunnel is up. We can actually see those interfaces. I was kind of worried. I think it's just because of packet tracers, so sometimes you don't see things just appearing when they should. So the state is now is up, so we can see the remote pair. We can see the remote pair. There's a remote pair here, and this is our one facing interface IP address of the Calgary router. And so let's see if there's traffic going through the tunnel. So first we want to do a ping. Let's try to do a ping from user 1 to user 2. What's the IP address of user 2, which is the tablet there? 10.10.10.50. Let's do a ping. Come here. Do a ping to 10.10.10.50. Okay, responding. Okay, which means traffic is going through the tunnel. Okay, and if we do a ping that 10.10. Let's say the FTP server 40, we don't have to ping everything, but okay, one packet failed, but the rest passed, so everything is good. If I do the Gmail SNMP, so it's going to be .30. This is expected. The first packet sometimes fails, just the time for the negotiation between the two edge routers. Okay, so now there is connectivity between the Calgary side and the Montreal side. Okay, so let's go into the router and see if packets are actually being encapsulated and decapsulated as we configure. So show crypto IPSEC Security Association, and if we check here, we can see 15 packets have been encapsulated and 13 decapsulated. Okay, maybe 2 packets failed. That's okay, because remember when we did the ping test, we were seeing some packets failed. Okay, so this one packet that failed here, another packet that failed. So we had another 2 packets that failed. So those 2 packets actually account for the what we're seeing right here. Okay, so 13 packets, 15 packets sent, only 13 received because 2 got lost. That's okay, which means everything is set up right and it's working. And it also means that we can now send an email from this user to this user. Okay, and we can also do, let's start with the FTP. Let's test if FTP is working. Let's go into user 1. come here and we'll just do FTP. We'll give the IP address 10.10.10.40. It's going to ask for username, which is, I set it to user 1. Okay. We're going to ask for password, which is Cisco 123. Okay. So our FTP is working. We'll do quit. Okay. Now let's test the Gmail. If that's we can send email from. No, before testing Gmail, let's test the the browser. The web server is working. We're going to go to dianebees.com, okay, and see if it's working. www.dianebees.com. If it's not working, then there must be something wrong. Maybe I didn't set up something the right way. Shouldn't take that long to work. Let me check. Alright, I know why it wasn't working. It's because this username, this user 1, when it was set up initially, we did not put all the like now the DNS server has to be 10.10.10.20. okay, that's the DNS server. Our default gateway hasn't changed. Okay, default gateway now has to be .1. Okay, I said by mistake. I think that's what I had here. No, I have HTTP working between this. So default gateway here has to be .100, I think. Let me just double check. Alright, so I found out why I was not able to reach the was not able to open the browser on the other side from this user. What happened is that when we set up the IP address for this user 1, we did not take into consideration that it's going to merge with another site. So the DNS server was wrong. The default gateway was correct, but for some reason, I think the real problem was just the DNS server. So I put the DNS server, and now we could ping the other site. Okay, let me just go in here. If I say ping www.dianebees.com, so ping is responding. So now if I go to the browser, if I go to the browser, I say www.dianebees.com, enter. Okay, now this page is there because we enabled HTTPS server here on this DNS server. So that's why we see this page. So we have DNS server working, we have HTTPS working, we have FTP tested working, and Gmail we haven't said. We have to send an email from user 1 from this user to this user. Okay, if user 2 is able to receive email from user 1, it means everything here is working, all connectivity is perfect. So let's just go into user 1. We're going to send an email. We'll go to email. We want to compose an email. So we're sending email to user 2, and our message is just hello. Say hi, user 2. Please confirm if you get my message. Regards user 1. So let's send it. Okay, message is gone. So let's go out of there. Okay, remember we are at this side of the network. So let's go to this side and go to the tablet, open it up, go to where we have the email, go to receive, because now we have received, we're not composing, we're not writing any message, we're just checking if we receive. Go to receive, and it's fair enough, we received the message right here. So it says received, it's success, which means we should be seeing, for some reason we're not seeing that message, but we should see the message popping up right here. Okay, we should see a message popping up here, and we're not seeing yet. So maybe we just have to wait a little bit. But the message actually says receive message success. Okay, so it actually tells who sent the message. So it's sent by this guy. Okay, 10 10 10 30. It's the sender. No, this is a receive. 10 10 10 30 is the Gmail server. Okay, that's the Gmail server that actually basically sends a message that's received from user 1 to user 2. So basically the message has been sent from user 1 to user 2, but for some reason we cannot see that message. But even though we see that it's received here, but we should also be able to see a message here, right here, that says that we received something from user 1. Okay, so we're not seeing that, and actually I went ahead and checked other things and realized that if I come to user 1, even though user 2 says we received an email, but user 1 gives an error. Okay, so it's an error. I don't know where to fix that, but I'll try to fix that. But the email itself, the email system is working. So say on user 1, it's saying that's a mail delivery system delivery failure. I see there. But on user 2, it says they actually received an email. Okay, all right. So basically, everything is working. Connectivity is working. Our main focus today was just the IPSEC VPN tunnel between Calgary and Montreal. That's done. So working perfectly. And this I don't want to make this video much longer than this. So thanks very much for always coming to my channel. If you're new here, please consider subscribing and leave me a comment so I know how I'm doing. And thanks very much, and talk to you next time.